You're welcome back. We want to name radicals and compounds having variable oxidation number. So how do we name radicals and compounds with variable oxidation numbers? Now, if you look at this is a radical. Of course, in our previous video, we have explained what we know as radicals. We said radicals are a group of elements which carries an electric charge. Now, for example, now if you look at these two radicals, we see that one is carrying a positive charge and the other one is carrying a negative charge. So how do we name these particular two radicals? The naming of these two radicals is ammonium ion. This is an ammonium ion. So this is an hydroxyl ion. Hydroxyl ion. This is an hydroxyl ion. So now, if you look at these two radicals, you see that anytime they are in a combination with an element, what ends it will be ammonium. What ends this will be hydroxide. So now that in naming acid radicals, we have what we call acid radicals. Acid radicals are radicals that carries a negative charge. You can see all of it carries a negative charge. So in naming acid radicals, oxidation number of the element is indicated by Roman numbers. What does that even mean? For example, now the name of this particular acidic radical is it has two, dioxonitrate. Now, dioxonitrate has an oxidation number. So how do we now determine the oxidation number that will be written in Roman numeral? Now, if you look at this compound, that is NO2 minus, the sum of all the oxidation numbers in this particular radical is equal to -1 because it's carrying a negative charge, so of 1. So that is the oxidation number of nitrogen plus that of twice that of oxygen will give us -1. So that of the central atom here, that is the nitrate, is what we are going to look for. So the oxidation number of nitrogen here will be determined if we follow this method. So it means that N plus 2 into the oxidation number of oxygen, of course, is -2. So we have -2 is equal to -1. So this becomes N plus 2 times 2, that's 4. That is plus 2 times -2 becomes -4. Is equal to -1. So N becomes -1 plus 4. So N becomes -3. So therefore, the oxidation number of nitrogen here, because we are talking about varying what? Oxidation number. The oxidation number of nitrogen here becomes what? 3. So it is dioxonitrate 3 ion. Dioxonitrate 3 ion. Dioxonitrate 3 ion. Now let's look at the next acidic radical here. What will now be the oxidation number of nitrogen there? So we have N plus, that is 3 into -2. The oxygen is -2. This is the 3 here. Is equal to -1. So this becomes N plus 3 times -2 becomes -6 is equal to -1. So this becomes N becomes -1 plus 6. So N becomes 5. That's -5. So therefore, the oxidation number of nitrogen here will be 5. So this becomes triozonitrate 5 ion. This is a triazonitrate 5 ion. So now let's have this. The oxidation number of carbon here will be, let's look at it, C plus, okay, we have 3 into minus 2, oxygen of course is minus 2, is equal to minus 2. So we have C minus, this is minus 6, that is plus 2, 3 times minus 2, that's minus 6, equal to minus 2. So C becomes minus 2 plus 6, that's what? 4. So this becomes trioxo, then carbonate, what? 4 ion. You can see the oxidation number is always written in what? Roman numeral. Now you discover, you discover it is not diazonitrogen. The nitrogen here becomes nitrate. So in the radical form, it is no more going to be nitrogen. It will become nitrate. You see, it's ending with ATE. The carbon here will no more be carbon, but what? Carbonate. Now let's look at this other one. We have sulfur here. Sulfur plus, that is 4 times minus 2 is equal to minus 2. So we have sulfur is equal to, this is sulfur minus 8 is equal to minus 2. Sulfur is equal to minus 2 plus 8, which is equal to 6. So now this becomes, 4 means tetra. This becomes tetra ozo. Sulfur, no, sulfate. Sulfate, what? 6 ion. Tetraoxosulfate 6 ion. You can see how the oxidation number of nitrogen is varying from radical to radical. So we can also have different oxidation number of carbon in different acidic radicals. So also we can have different oxidation number of sulfur in different acidic radical. So that is naming of radical and compound having varying or variable oxidation number. Thank you.